The way this started was back in actually the mid to late 90s. I worked on a DARPA project on the development of electromagnetic pulse weapons and auditory weapons for DARPA. I don't know what DARPA is, but so I got very familiar with how to change brainwave patterns with light frequencies. We actually built weapons that could do that. The first one was deployed in the first Gulf War. You probably saw the 500,000 Iraqi soldiers march out of the desert. They threw their weapons down. This is what was deployed along with what's called LRAD, long-range acoustical devices. All of my work was done at Brooks Air Force Base in San Antonio, and MIT, through the Picower Institute, and we're going to see a video on it, they figured out what causes Alzheimer's and how to stop it. And I'm going to show you a video that, that they've done. But the way that they did it is they took the rats, gave them Alzheimer's, drilled holes in the rats' heads, inserted a fiber optic, and then they flashed light onto the occipital lobe of the brain, and their Alzheimer's reversed. The rats could relearn their mazes. And when I contacted Dr. Li Wei Tsai, because I had this device. This device is made here in Leesville. It's assembled and programmed here. There's 256 parameters that go into this. We could put a feedback loop on where you wear a skull cap, and it feeds back in. By changing light frequency, I can change your brainwave pattern. So it depends on what you want to generate from that. This device will do it. So when I contacted her, she said, she asked if I had such a device, and I said yes, so we sent it to her. And they ran it through a series of tests, and it stops the progression of Alzheimer's. There are 7 stages to Alzheimer's. You're not even diagnosed until stage 3. Not everybody that has their memory loss is going to get Alzheimer's. But 100% of everybody who got Alzheimer's started with memory loss. So it's not even diagnosed until stage 3. At stage 6, you are in an inflammatory state of almost brain atrophy. You fear, you don't know anything, you can't feed yourself, you can't dress yourself. That's a pretty tough position to be in, and it's terrible. How many people here have or know somebody suffering from dementia or Alzheimer's? It is everywhere, and it is a terrible disease. It is just the long goodbye, but now we can stop it. And this was all funded through me. I didn't trust anybody else at that time. So when we sent it to MIT, they began to look at it, and we ended up with these 3 goals. What's the cause of Alzheimer's? How do you prevent Alzheimer's disease? And how do you stop the progression of it? So when we began to focus on those 3, these are all the inflammatory diseases caused by 4 free radicals called reactive oxygen species. Superoxide, singlet oxygen, peroxyl, and the hydroxyl free radical all make up ROS. There's also a nitrite free radical. But these are all the diseases that result from excess ROS in our bodies. If we can cut that trunk of that tree and eliminate the ROS, all these diseases will go away. And we now know how to do that, by the way. A free radical is nothing more than a molecule that has an unpaired electron. So no matter what it touches or bumps into, it'll steal an electron from it. So if it's the DNA it bumps into, it'll steal an electron from the DNA will mutate, and now you have cancer. It happens, we produce, the simple fact that we breathe oxygen means that we have to deal with this every day. When we're young, we produce an antioxidant called glutathione. We generate a lot of bad habits and get away with it. I could stay up late, I could eat pizza, I could drink alcohol, I could smoke cigarettes, I could do anything that created stress in my life, raising kids, work. But those habits we generate, an average age of 42 in women, age 50 in men, the glutathione production in our bodies goes to zero. And when that happens, we haven't changed our habits, but we no longer have the protection, so we get inflammatory diseases. It's nature's way of taking us out. So that's where the Velasta comes in. We eliminate those free radicals, and that's what Velasta does. These are the, hope you're all taking notes because there will be a test after this, but these are the reactive oxygen species. These are the 7 stages of Alzheimer's, and I'm going to focus now on the inflammatory cause of Alzheimer's. Stage 1, no impairment. Stage 2, very mild decline. Stage 3, that's where somebody knows something is wrong. And the best analogy I had is you've lost your car keys. Somebody without Alzheimer's finds the car keys and can put them in their car and drive away. Somebody with Alzheimer's finds their car keys and they don't have a clue as to what they're for. That's the first stage of observation, is the confusion part of Alzheimer's. So you can see from stage 3 up to a late stage 5, really. It shows there stage 6, but we only have 3 stages to correct this. At stage 6, you've got to make a real serious moral and ethical decision. Do you want to stop your loved one that can't remember anything, can't feed themselves, can't dress themselves, can't go to the bathroom by themselves, and stop them at that point for the next 20 years of their life? And that is a very ethical discussion that has to happen, because in some cases, this device, you wouldn't apply it. You would let them move through that period. And those are very, very difficult decisions to make. Stage 6, the brain starts to shrink. They can actually pick it up on an X-ray. The neurons are dying, and the brain's getting smaller. Stage 7 is terminal. Here's the 4 ways that we see in the prevention of Alzheimer's. So you want to reduce the amount of free radicals floating around in your body. There's actually a blood test. It's called an HSC reactive protein test. If that number is under 3, you won't get these diseases. If that number is greater than 3, chronically, you're going to get one of these diseases is going to present. It could be arthritis, irritable bowel, diverticulitis, Crohn's, type 2 diabetes, MS, Alzheimer's, Parkinson's. But there's some other things very important. Fructose, alcohol, and smoking are probably the 3 biggest ones. Fructose is a poison in our food system. The FDA acknowledges that it's a poison, but they only regulate acute poisons. They don't regulate chronic poisons. Fructose was allowed in our food system in 1966. And it can't be used by a single cell in your body. It is an absolute poison that causes LDL cholesterol. Your high cholesterol comes from fructose. Doesn't come from animal meat and oils like we've been told. It's all in the consumption of fructose. So fruit, when we all started out, go back to just the 1800s, early 1900s, the only time we ate fruit was maybe 2 or 3 months out of a 12-month year when the fruit came ripe. Now what do they tell you? You got to eat fruit every day. So instead of running an inflammatory disease state like this, you eat fruit, you get it, you like the taste of it, but you get an inflammatory spike. Then you got 10 months to heal from that. Now, way they recommend is fruits and vegetables. Fruits keep you at a chronic state of inflammation. You eat it every day. and you're going to end up with chronic disease. I'm not going to go too much into this, but those are the damages that ROS can happen. DNA, protein damage, misfolding of insulin for insulin resistance. That's the primary cause of insulin resistance and type 2 diabetes. This is a misfolded protein. So when a protein is, see if I can do this. Here, when a protein's made from your DNA, it looks like a string of spaghetti. And then it goes in and it's folded perfectly each and every time into a gob. And it turns out that there's only one little site on that protein that's functional. After all this folding, only one, it has to be folded perfect so that that insulin can make contact with the insulin receptor on your cell to allow sugar to enter into your cell. If this protein, let's say that's the wadded up protein, perfectly folded, and that's the functional group, it will fit perfect. Now, if it hits a reactive oxygen species, it does this. Now, how do you find, this is called type 2 diabetes. This is what causes it. You can't open up the glucose channels to the cell and allow sugar to flow into the cell because it can't find it. So ROS is very important. But in the brain, MIT found what causes Alzheimer's. And it's these misfolded amyloid molecules. They'll form a plaque. And they'll coat the axon that goes from this nerve down to another nerve. It will coat it. And the insulating material called myelin will be eaten off of that axon. It's like a wire, you strip the insulation off, it short circuits. Now you no longer have that memory. It'll eventually kill that nerve cell. So here's a little bit of it here also. This is the amyloid protein here. There's little things in our brains that it's hard to talk about them because we don't know what they are. They're not human. They have no DNA in them. They're called microglia. Microglia are little organisms that clean our brain. They swing from neuron to neuron on their little tentacles, looking for debris in our brain to consume. In a healthy brain, we have a lot of microglia. They're with us from the day we're born until the day we die. They never reproduce. They just live in there, almost like a parasite. So what happens is when we get older and our energy level drops, the microglia become less energetic. And they will no longer consume the amyloid beta plaque that forms. So if the microglia slow down, the amyloid beta plaque levels increase. More and more neurons get coated with this paste, this glue, and the neurons die. This is what MIT found is what causes Alzheimer's disease. Here's the misfolding of the protein. There's 3 types: plaques, tangles, and Lewy bodies. ALS. Does anybody know anybody that's got ALS? ALS is Alzheimer's of the body. It's the same plaque formation, except it happens in the nerves in the body. Alzheimer's happens in the brain. But these are all caused from ROS and from misfolding of protein. So if we eliminate the misfolding of the protein, we don't get Alzheimer's.
1 in 3 adults in the United States will die from Alzheimer's or age-related dementia, touching almost everyone as a patient or a caregiver. There are now 46 million people with Alzheimer's disease worldwide. The total societal costs associated with dementia will reach $2 trillion by 2030. Alzheimer's expenses are the greatest direct healthcare cost to the United States economy. greater than cancer and heart disease. New approaches to treat and reverse Alzheimer's disease are needed. Recent studies suggest that Alzheimer's disease disrupts brain signaling and how neurons synchronize. This specific type of neuron synchrony, altered in Alzheimer's disease, is called the gamma rhythm. Sensory information from our environment is critical to how the brain synchronizes and communicates, which aids in our ability to remember loved ones' names, recall what we did last week, and to pay attention to where we put our car keys. Altered gamma rhythms in Alzheimer's disease are due in part to the toxic accumulation of a SNP protein called amyloid beta, resulting in fewer neurons firing in synchrony. Research from the lab of Director Li-Wei Tsai of the Picower Institute for Learning and Memory at MIT has sought to understand how Alzheimer's disease affects gamma rhythms in the brain, under the premise that abnormal neuronal firing populations play a key role in the symptoms of the disease. First, Dr. Tsai's team established that the gamma rhythm amplitude at the 40 Hz range was reduced in mice with Alzheimer's disease, called 5X FAD mice. More specifically, the gamma rhythm was significantly decreased in a brain region crucial for learning and memory, the hippocampus. The diminished gamma rhythm in 5X FAD mice occurred with the accumulation of amyloid beta, which eventually becomes toxic and results in neuronal death and memory loss. Next, researchers in her lab used optogenetics to artificially correct the gamma rhythm in the hippocampus of 5X FAD Alzheimer's mice.
Let me study that little fiber optic come in. What MIT did is drilled holes in rats' heads and inserted that fiber optic in to flash light onto the occipital lobe of the brain. And this is the part that we came into, that we contributed to.
Correct the gamma rhythm in Alzheimer's mice activated genes in brain cells called microglia. Microglia are part of the brain's immune system and function, in part, to ingest or clear away microorganisms that might cause disease. Optogenetic stimulation at the 40 Hz range activated microglia to promote the clearance of amyloid beta. To create an effective treatment in humans with Alzheimer's disease, it's ideal to invent a non-invasive technique. To this end, Li-Wei Tsai and her team created a sensory paradigm that uses flickering light to restore the gamma rhythm and to reduce the levels of amyloid beta. 5X FAD Alzheimer's mice were exposed to 40 Hz flickering light, which caused enhanced gamma rhythm neuronal activity and reduced amyloid beta levels by over 50% in the visual cortex. In addition, the 40 Hz flickering light treatment caused microglia in Alzheimer's mice to become more active and dramatically increase in size by engulfing amyloid beta. When the gamma flickering light treatment was used in older Alzheimer's mice with toxic levels of amyloid beta, which results in aggregates called plaques, the plaques decreased. However, for the plaque levels to remain low, the flickering light treatment had to be given over several days versus hours. This unique, non-invasive approach might lead to the development of treatments that can affect the disease without the current pharmacological challenges of the blood-brain barrier or unexpected drug interactions. This technique is a big step in finding new and effective treatments for Alzheimer's disease that one day...
I'm going to stop it there so you sort of get the drift as to where this is going. We currently have about 500 of these out, stopping the progression under what's called the Montreal Protocol, where they test you for Alzheimer's disease. They're coming back with the same scores. Slight improvements. I've got one 88-year-old lady who we just got an email from her son. He's a preacher up in North Baltimore, Ohio. He got the device. She was sitting in a corner babbling, 88 years old. Couldn't do anything. We put her on the light, and within 30 days, she not only remembered her children's name, remembered her dead husband, could now feed herself, and could actually play Scrabble. She lived to be 93, had her mind all the way up until the day she died. She died of COVID from them. This is this simple. Tommy and I watch it every day. I turn on the news, turn my light on, have a cup of coffee. As long as it's in your peripheral vision and those photons can get into your eye, your eye is very good at converting that same frequency into electricity down your optic nerve, and it dissipates in the occipital lobe of the brain. This is a low end. We block out the epileptic frequencies, and then this is the frequency that, and it keeps the microglia active, and you won't have any dementia, no Alzheimer's. Parkinson's is a little different. Parkinson's, Lancer?
Yeah, Sam, so in the studies, do you, will the brain get acclimated to that wavelength and then stop responding? And then you have to change the wavelength because it's acclimated to it?
Not with this, because this is direct energy. Your brain doesn't get resistive to energy. If you put your finger on a 300-degree oven, it will burn you 100% of the time. Energy is a little different. But when you start looking at mass, like insulin resistance, for example, you can get resistant to insulin simply because your body adjusts with reactive oxygen species to derate the insulin. So what we're doing is we're making these available. You can give it to family members. They work great. I've got one gentleman right now, too many drugs, alcohol, pretty tough life. Ended up with bipolarism from marijuana use, schizophrenia, and
Can you go
it's
back
direct.
to Parkinson's right quick?
Yeah. On the Parkinson's, up until this point, everyone thought it was a lack of dopamine production in the brain. And so what they would do is they would treat the symptom. They would give you levodopa or carbidopa to make, and pretty soon you get resistant to that. And you crater off into Parkinson's, tremors, and hallucinations and all that. Well, what we found, that isn't it. The brain in Parkinson's patients called the substantia nigra is producing large amounts of dopamine. The problem is it's reacting with a hydroxyl free radical, and it's forming a compound called oxydopamine. Now, oxydopamine is what we give to animals to give them Parkinson's so that we can test Parkinson's medications on them. But in Parkinson's patients, we find the oxydopamine to dopamine ratio is very high, which means if you reduce the hydroxyl free radical, the ROS, it should stop. So we gave people Volasta, and it knocked their C-reactive protein under 3, and their Parkinson's tremors stopped. No levodopa, no carbidopa, no hallucinations. They sleep through the night. So the whole premise as to what is causing Parkinson's isn't right. It's not a lack of production of dopamine. It's a reaction of dopamine into oxydopamine is what's causing the problem, by the way. And that's going to shake
stops
the hydroxyl free radical.
But there is like a lot of plaque, especially in those people, and so by using the light with the Volasta, it helps.
It's the same thing. It'll shut down the microglia, and in Parkinson's patients, we also see a lot of amyloid beta plaque buildup too. So the light with Volasta is really the protocol that we use. Yeah.
Any other questions for Sam? Or Meryl?